There is a specific kind of quiet that only exists late. Not silence exactly. Silence is the absence of sound, and this is not theta. This is something more like a sound that has been running so long it no longer registers. The hum of a refrigerator, the pressure of air through a vent somewhere, the way a building just sits there, doing whatever buildings do at this hour, and you stop noticing all of it until one of the sounds stops, and then for a moment, everything feels slightly wrong without it. You are on Sleepy Science Channel, which maybe you already knew, or maybe you came here sideways, through a recommendation, through someone else's watch history, through the particular late-night gravity that pulls a person towards something that sounds like it might be worth thinking about. Either way, you are here. The hour is what it is, and if you are still here, still watching, still listening, that means something to the people who make this, more than a thank you would adequately cover. The fact that this channel is still going, still making things, is because of that. Because of you in the specific and non-abstract sense. Something about tonight feels slower than usual, though it probably isn't. The Earth is about 4.5 billion years old, and for most of that time, it has been a completely different place. This is the kind of sentence that is easy to read and almost impossible to actually absorb, because your brain will accept it as a fact and file it next to other facts and move on, which is the sensible thing to do and also a way of never really letting it land. So before we go anywhere with it, just sit with the number for a moment. 4.5 billion years. A billion is already past the edge of what human intuition can hold. 4.5 of them is just somewhere past that edge, in a direction you cannot quite look. What we know is that the Earth did not always look like this. The oceans were different, the atmosphere was different. The continents were arranged in ways that make current maps feel almost temporary, which they are. And the moon was different in a way that changes what the whole planet felt like, from the ground up, from the ocean out, from the air down. The moon was closer, not a little closer, about 3 times closer than it sits tonight. Before you try to picture that, notice that you are already doing something with it. Your brain is taking the moon as you know it and trying to move it inward, making it bigger in the sky, maybe brighter, maybe more present. That picture is not wrong exactly, but it is missing most of what the difference would have actually felt like. Because proximity, when it comes to the moon, is not just about what you see. It is about what you feel, what the water feels, what the ground, in its slow way, feels. The moon, at 3 times its current distance, was not just visually bigger, it was gravitationally louder, which is a strange phrase because gravity does not make a sound. But if you have ever stood close to something very large and felt something in your chest that was not quite fear and not quite awe, but was in the neighborhood of both, you have some dim approximation of the kind of presence the early moon would have had over everything on this planet. The tides it generated were not like tides you have seen. Think about a coastline, the way the water comes up slowly, higher than you expected, and then pulls back, and there is a strip of wet sand that was not there an hour ago. The rhythm of it, the patient, indifferent rhythm of it. High tide, low tide, roughly twice a day, a few feet of difference in most places. That rhythm, that quiet, twice daily, entirely ordinary rhythm, is what is left over after 4 billion years of the moon moving away. What it was before is something that does not have a clean human comparison. The tidal range in some locations today reaches over 15 meters, which is already extreme enough that people who have not seen it find it difficult to believe. In the early Earth, with the moon at roughly a third of its current distance, tidal forces were on the order of many times stronger. The ocean did not come and go in the way you are imagining. Walls of water moved across basins. The boundary between ocean and land was not a line. It was a negotiation that the ocean was winning. Twice a day, every day, with a force that left no record of itself because nothing was there yet to keep records. There is a word for the kind of knowing that arrives through the body rather than the mind. You have experienced the thing it describes. You have been in a place and known before you had reasons that something large had happened there, standing at the edge of something very high, being in the ocean past the point where your feet can touch. That specific quality of understanding that bypasses language and arrives already complete. What this chapter is reaching toward is something like that. Not an explanation of the early Earth, just the texture of a world that was doing everything the current world does, rotating, holding an ocean, keeping its moon, but doing all of it at a volume that nothing alive today has any access to. The shore remembers nothing. Shores do not have memory. The rock at the waterline does not know what happened to it 3 billion years ago. But you are made of things that were there, distantly, indirectly, in the way that everything on this planet is made of things that were here before anything was alive to use them. The water in you has a history that goes back further than cells, further than chemistry as anything would have recognized it, further than almost any reference point that feels real. The ocean moved through your ingredients once, with a force that would have. It is a strange thought. You do not have to finish it. You are lying somewhere, probably. The room has a sound. It is the sound of a place that is not doing very much right now. This sound, this particular quality of late-night quiet, is a very recent invention. Recent in the way the last 100,000 years is recent, relative to everything else. You are living in the aftermath of something that has been cooling for 4 billion years. The world you are in is what happens when a planet and its moon reach an arrangement, when the energy settles, when the tides that once moved like catastrophe learn, over an almost incomprehensible stretch of time, to move like weather instead. The shore does not remember, but the distance between here and that sound is exactly as large as the universe allows, and we have only just started measuring it. You already have a model of the moon in your head. Everyone does. It is not accurate, but it is functional. It is the thing that rises, the thing that is sometimes full and sometimes a crescent and sometimes so thin it looks like someone left a light on by accident. It is the thing that is always roughly the same size, which is one of those facts you absorbed so thoroughly you stopped noticing it was a fact at all. Here is the problem with that model. It was built entirely from experience of the moon at its current distance, and distance, when it comes to the moon, is not a neutral measurement. It is the variable that determines almost everything about what the moon is doing to this planet and to the water covering most of the surface you are sleeping on right now. So when someone says the moon was once 3 times closer, your model does something reasonable. It takes the moon it knows and moves it inward, makes it bigger in the sky, maybe brighter. That adjustment is not wrong. It is just very, very incomplete. Start with the visual, because it is the easiest part and also the part that matters least. The moon at 1/3 of its current distance would have covered an angle in the sky roughly 3 times wider than it does now. The full moon tonight occupies about 1/2 degree of arc. Hold your pinky finger at arm's length. The moon fits behind it with room to spare, which most people find mildly surprising. the first time they try it, because the moon always looks larger than that. At 3 times the angular size, it would have covered about 1.5 degrees, still something you could cover with 3 fingers at arm's length. The sky is 180 degrees from horizon to horizon. Even a moon 3 times its current visual size would have occupied a small fraction of that. The visual is not the story. The story is gravity. Specifically, what happens to gravitational force when distance changes. Gravity does not scale linearly with distance. This is the part the model in your head almost certainly got wrong, because linear scaling is how most things work at human scales, and the brain applies it everywhere by default. If something is twice as far, it seems like it should pull half as hard. 3 times as far, 1/3 as hard. Intuitive, tidy, wrong. Gravity follows an inverse square relationship, which means that if you reduce the distance by a factor of 3, the moon at 1/3 of its current distance, the gravitational force does not triple. It increases by a factor of 9. 9 times, not 3. Sit with that for a moment, because it tends to slide past on the first reading. The tidal force, the differential pull across the diameter of the Earth, the part that actually moves the ocean, scales even more steeply, as the cube of the distance rather than the square, which means the tidal forcing at 1/3 the current distance was not 9 times stronger, it was 27 times stronger. 27. The ocean under 27 times, the tidal forcing would not have behaved like a larger version of itself. It would have behaved like something that does not have a name in any language, because nothing alive has ever seen it, and the geology that recorded it has mostly been recycled by a planet that does not keep good notes. There is something that happens when a number gets large enough. It stops feeling like a quantity and starts feeling like a category. You cannot go to a beach and think, now imagine 27 of these, because it is not 27 of these. It is a different thing entirely, operating by the same rules but producing outcomes that share almost no surface features with your reference point. 27 times, every day, for hundreds of millions of years. What the inverse square law is doing underneath all of this is something quiet and structural. It describes the geometry of how force spreads through space. When a gravitational source pulls on something, the pull weakens as it spread outward. Not because the force is running out of something, but because the same force is covering a larger and larger area. The way light from a lamp hits any given patch of wall more faintly as you move away. The force is conserved. It is just spread thinner. Closeness is not just about being near something. Closeness is about being inside a region where the force has not yet had room to spread. The early moon was not pulling harder because it had more gravity. It had the same gravity, the same mass, the same basic character. It was just close enough that the Earth was sitting deep inside the field before it had a chance to thin out. The moon did not change. The Earth did not change, not in the relevant way. What changed was the distance, and the distance changed everything, according to a rule that has no exceptions and no mercy, and does not care at all what your intuition expects. There is a version of this that would spend more time on the mathematics. That version is accurate and would give a more thorough picture. But what seems more worth doing here at this hour is sitting inside the gap between what 3 times closer sounds like and what it actually means, because that gap is the inverse square law made personal. You have almost certainly said at some point that something was hard to imagine. Usually you say it, and then imagine it anyway, imperfectly, and move on. But there are places in science where the correct response to hard to imagine is not to imagine harder. It is to stop, to let the number stand there, to acknowledge that your intuition was built for a world of human scales, and that it is genuinely not equipped for this one, and that this is fine. The moon was 3 times closer. The force was 27 times stronger. The difference between those two sentences is the whole thing. Something about the night sky has always made people feel small. You have maybe stood outside in a place dark enough to actually see stars and felt something drain out of you. Not 0.0 of the solar system, basically next door. And yet, even at next door, the inverse square law still managed to make 3 times the distance into 27 times the force. The geometry of space is not impressed by what counts as nearby. The moon sat where it sat. The numbers were what they were. And the Earth, indifferent to how any of this would eventually be calculated, just felt it. Felt all 27 times of it, twice a day, for longer than there are words for long. Something is spinning, not fast enough to see, not fast enough to feel, the way you feel a car accelerating, but fast enough that if you were standing on it, if you had mass and weight and the friction that keeps a body attached to a surface, you would feel a slight outward pull at the equator, a loosening, the ground trying very gently to let go of you. The Earth is spinning. It has always been spinning. This is not new information, but it was spinning faster, much faster. 4 billion years ago, a day on Earth lasted somewhere between 4 and 6 hours. The estimates vary depending on which rock record you are reading, but the range is tight enough to say a full rotation, sunrise back to sunrise, in the time it now takes to get through a morning. 4 hours, maybe 6. The sun rose, the sun crossed the sky. The sun went down, night came, and then it was morning again. All of it in the span of what you might now spend at work, or asleep, or watching something without really watching it. This is not a metaphor for anything. It actually happened. The reason is angular momentum. A spinning figure skater pulls their arms in and speeds up. The Earth, newly formed, had been struck by something enormous, the collision that created the moon, and was left rotating fast. And there was nothing yet to slow it down. Nothing yet. That phrase is doing a lot of work, because something did slow it down, is slowing it down. Right now, tonight, imperceptibly, the Earth's rotation is being braked by the same moon that caused the early speed, through the same tidal forces described in the previous chapter, and the day is getting longer, has been getting longer, by about 1.4 milliseconds per century, which sounds like nothing, which, across 4 billion years, adds up to the difference between a 4-hour day and a 24-hour one. Here is where it gets strange, in the specific way that things get strange when you follow time out far enough. The moon was closer then, and the tidal forces were 27 times stronger, and those forces were doing something specific, creating a bulge in the Earth's oceans, a slight swelling on the side facing the moon, and the Earth, spinning fast, faster than the moon was orbiting, was carrying that bulge slightly ahead of the moon as it rotated. The bulge was like a handle, and the moon was pulling on that handle, pulling it backward relative to the Earth's spin direction, slowing the spin. Every tide that ever came in was a small braking event. Every tide for 4 billion years. And the energy taken from the Earth's spin had to go somewhere, because energy does not disappear. It went into the moon's orbit, into the moon's speed. And when an orbiting object gains speed, it does not move faster around its orbit. It moves outward to a higher, wider orbit, further away. The moon moved away because the Earth slowed down. The Earth slowed down because the moon pulled on its tides. The tides were strongest when the moon was closest. The whole thing is a single system, running for 4 billion years without stopping once. Go back to the 6-hour day for a moment, because the mechanism can pull attention away from what the experience of it would have been. 6 hours, dawn, then dusk, then dark, then dawn. The sky moving at 4 times the speed you are accustomed to. Stars rising and setting in under 90 minutes. The sun crossing the sky, not in the long, almost imperceptible arc you can watch on a clear day, but quickly enough that you might actually notice it moving. If you looked away and looked back, weather would have been different. The fast rotation drove stronger Coriolis forces, the effect that curves moving air and water because the ground beneath them is rotating, which means the early atmosphere circulated differently, more violently, in tighter and more numerous bands. Storms were probably smaller in diameter and more intense. The planet was a different machine, running at 4 times the speed, pulling harder on everything that moved through it. There is something almost uncomfortable about imagining days that short. Not frightening, just wrong feeling, the way certain optical illusions are wrong feeling. Your body has a clock, several of them, layered and cross-referencing, adjusted by light and temperature. Those clocks are calibrated to 24 hours. They developed over hundreds of millions of years of life on a planet with a day of roughly this length, and they are woven into your biology at a level that is not optional. You do not choose to feel tired at a certain hour. Something older than choice is doing that. On the early Earth, whatever was alive had no such clock, could not have had one. The light came and went too fast to anchor a metabolic cycle to. What rhythms existed were tidal, not solar. The moon, closer and louder and 27 times more forceful, was a more reliable drummer than the sun. Life organized itself around the moon before it organized itself around the sun. The day lengthened. Slowly, 1.5 milliseconds per century. 4 hours became 6, 6 became 12, 12 became 24. And somewhere in the long middle of all of this, life was adjusting, not intentionally. But the organisms that happened to have metabolic rhythms close to the current day length were the ones that fit the world they were living in. And fitting the world you're living in is, very loosely, what survival is. Your circadian rhythm is, in some dim and distant sense, a record of where the Earth was in its slowing down process, at the time your particular evolutionary lineage was doing the relevant fine-tuning. Your body knows what length the day should be, because your ancestors lived in days that were that length for long enough that the rhythm got written in. Which means the 24-hour day is not a neutral backdrop to your life. It is part of your biology. It is in the timing of your hormones and the architecture of your sleep and the particular drowsiness you may be feeling right now. The Earth slowed down. You were calibrated to the speed it landed on. Something about that chain, moon closed, tide strong, Earth breaking, moon retreating, day lengthening, life adjusting, body calibrating, feels like it should have a different name than physics. It is physics, precisely, boringly, correctly physics, but it is also the reason you feel the way you feel at this hour. The 6-hour day is gone, has been gone for longer than there is any useful way to say. The planet settled into its current rotation gradually enough that nothing alive ever experienced the change, only the accumulated result of it. And the result is this length of night, this particular hour. The darkness outside and the sounds of the building and the specific weight of being awake past the point where being awake makes straightforward sense. The day used to end 3 times before this moment would have arrived. It doesn't anymore. Before it happens, there is a moment, not a pause. The system does not pause, but a held quality. The way a very large wave looks still for a fraction of a second at its peak before it begins to fall. The ocean is full. The moon is directly overhead. The water has been climbing with 27 times the force that moves your current ocean, and it is about to arrive. This is the moment the chapter opens in, not the crash, not the aftermath, the moment just before. Sound is not what most people think it is. Most people think of it as something that travels through air, which it does, but air is just a medium, a particular arrangement of molecules that can pass compression waves from one place to another. Sound will travel through almost anything that has mass. It travels through water faster than through air, and through steel faster than through water, and through the ground at speeds that depend on the density of the rock. Sound is a pressure phenomenon, and pressure does not care what it is moving through. The early Earth had an ocean, it had atmosphere, it had a crust still cooling, still finding its final arrangement. All of these were available for compression waves to move through, and the tidal events happening twice per tidal cycle were generating mechanical energy on a scale that put energy into all of those media simultaneously. Think about what happens at a coastline during a large tidal event even now in the current ocean with the current moon. Water moving against rock is not quiet. The compression of air in sea caves, the slap of water against vertical surfaces, the low-frequency rumble that travels through cliff faces and arrives in your feet before your ears register anything. These are all real, documentable, the kinds of things people describe as feeling rather than hearing when close enough. Now scale the tidal force by 27. The water arriving at a coastline under that forcing was not a larger version of a current high tide. The fluid dynamics at that scale produce phenomena that are qualitatively different, not just quantitatively different. The way a river behaves differently from a trickle, not just faster and deeper, but fundamentally different in the structures it forms. Tidal flows at early Earth magnitudes would have produced behaviors that current oceanography does not have strong observational analogs for. What this generated acoustically in the full, medium-agnostic sense was its energy in frequency ranges from infrasound, below what any ear can detect, up through ranges that would have been audible to any organism with the right equipment. The infrasound component matters especially. Infrasound travels enormous distances with very little attenuation. It passes through rock. It passes through the body. Animals today use infrasound for long-distance communication. Elephants, whales, certain birds before storms. The early Earth was generating it constantly from every coastline, every tidal channel, every place where moving water met anything solid enough to push back. The planet was ringing, not loudly the way an explosion is loud, continuously the way a bell rings after it has been struck, except the striking never stopped. You have a threshold for sound you are not usually aware of, not a hearing threshold, a feeling threshold. The point at which sound stops being something you perceive with your ears and starts being something your body responds to without your permission. Very low frequencies at sufficient amplitude cause nausea, disorientation, a feeling that something is wrong, that your brain cannot locate the source of. This is well documented. The early ocean was not trying to disorient anything. There was nothing yet to disorient in any complex sense. but the mechanical energy it was releasing was real, and it was propagating, and anything that had mass and was somewhere on this planet was inside it. The night was not loud because there were things making noise. The night was loud because the planet itself was a resonating system, and the moon overhead was striking it twice per tidal cycle with a force that put energy into every medium available. This is what the tidal means, not a metaphor, a physical description of a planet doing something it no longer does at anything like this intensity. Now the mechanism, because the noise was not just noise, it was a transaction. Every tidal event was an exchange of energy between the Earth and the Moon, and understanding the direction of that exchange is the part that changes how everything else in the story feels. The Earth was spinning fast. The Moon was orbiting more slowly than the Earth was rotating. This mismatch is critical because the Earth was rotating faster than the Moon was orbiting. The tidal bulge was being carried forward by the Earth's spin ahead of the Moon's position. A small angular offset, but enough. The Moon was pulling on that bulge, and the bulge was slightly ahead of the Moon. So the Moon's gravity was pulling the bulge backward toward the Moon's position, which meant it was pulling against the Earth's rotation. A braking force applied every moment, continuously. The Earth was losing rotational energy. Where was it going? The energy was going into the Moon's orbit, not through any physical link, through gravity. The tidal bulge ahead of the Moon was pulling the Moon forward, the same gravitational interaction, acting in the opposite direction. The Moon was being accelerated in its orbit, very slightly, continuously. Every tidal cycle, a tiny increment of the Earth's rotational energy was being transferred to the Moon's orbital energy. And when an orbiting object gains energy, it moves to a higher orbit. This is counterintuitive. More energy means moving slower in a larger orbit. But it is correct, and it has been verified to very high precision by laser ranging equipment bounced off reflectors left on the lunar surface by Apollo missions. We are not guessing about this. We have measured it. The Moon is currently moving away from the Earth at 3.8 centimeters per year, and the mechanism is exactly what has just been described. The Moon moved away because the Earth slowed down. The Earth slowed down because the Moon pulled on its tidal bulge. The tidal bulge existed because the Moon was there to pull the ocean toward it. The system is circular, self-contained, and has been running since shortly after the Moon formed. Let the circularity sit for a moment without trying to find an entry point or an exit. The Moon created the tides. The tides break the Earth. The breaking sent energy to the Moon. The energy moved the Moon outward. The Moon moving outward weakened the tides. Weaker tides break the Earth more slowly. Least energy transferred per cycle. The Moon moved outward more slowly. The whole system carries within it the mechanism of its own moderation. It was always going to end up somewhere quieter. The physics guaranteed it. What it did not guarantee was how long it would take or what would happen on the surface of the planet while it was happening. The noise and the mechanism are the same thing. Every tidal event that put energy into water and coast and air was also, simultaneously, the same event transferring a small increment of angular momentum from the Earth's spin to the Moon's orbit. You cannot separate them. The acoustics and the orbital mechanics are not two things happening at the same time. They are one process viewed from two different scales. At the scale of a coastline, it was water arriving with enormous force, vibrating rock, generating pressure waves in every available medium. At the scale of the Earth-Moon system, It was angular momentum moving from one body to another incrementally over billions of years. The noise was the mechanism making itself audible. There is something almost difficult to accept about this, because the early Earth, described at the scale of coastlines and pressure waves and infrasound, sounds like a violent place. And it was, but the mechanism driving it was not violent. The mechanism was gravity, which is the most patient force in the universe. Gravity does not rush. It pulls at every moment according to a rule that has no exceptions, and it does not get tired. The moon was not trying to move away. The earth was not trying to slow down. These things happened because they had to, because the geometry of the situation and the physics of angular momentum left no other option. The whole 4 billion year transaction was not a choice made by either party. It was a solution the system was always moving toward, one tidal cycle at a time. And the noise was what it sounded like while the solution was being worked out. What you are left with is a specific texture. The early Earth, spinning fast, lit by a moon that filled more of the sky, making a sound in every medium that was not quite sound and not quite silence and not quite anything that currently has a name, while the patient force of gravity slowly moved the moon outward and the days grew longer and the tides shrank and the planet got quieter, incrementally, imperceptibly, over a span of time that makes the word long feel like an insult to the duration involved. The mechanism is still running. Right now, the moon is 3.8 centimeters further from the Earth than it was a year ago. The day is 1.4 milliseconds longer than it was a century ago. The tides are still breaking the rotation. The energy is still transferring. The noise stopped. The mechanism did not. It is still settling something. Whatever quieter configuration the Earth and Moon are moving toward, they have not arrived there. The system is still in transit, still working something out, still moving 1 centimeter at a time toward an arrangement that will exist long after there is anyone to notice the silence.